Okay, listen up. This is ECE, Electrical and Computer Engineering, 3080 ethics in electrical and computer engineering. And I'm Professor Passino. We talking with you this semester about this class. There is a number of things I want to discuss initially. Number one, the microphone is for recording because there's some a different class that's related to this that's running off of online. I will also be posting the recordings. The recordings will be constituted. You won't see pictures of me, which I know you don't care about anyway. You'll hear the audio and you'll see the screen recording. The slides are all posted at my website. Okay, so you can catch up by looking at those. Okay, so let's get started. So in electrical and computer engineering, you might ask the question is, what is it that you're becoming when you become an ECE? ECEs generally have been defined by what they do, and that may be why you got into this particular field, because you see the advancements that the field has made, for instance, in computers. Okay, and you say that's really cool. This field seems like it has a long-term future. I'm going to get involved in it. Okay, so we've done many other things. I'll talk about those in a minute. But you might ask, well, since 1884, when electrical engineering was first formed out of people like Benjamin Franklin and the Franklin Institute, and then not the IEEE, but the IRE, the Institute of Radio Engineers. Okay, you might ask, how will you fit into the flow of ECE history? You might want to read that. There's quite a few publications out there that are really good. I know you're not going to read those this semester, but they make for good reading perhaps later in life. And I would recommend you go to the Actual History Center to see what they have. So what will you contribute? What you will contribute will either come from your job in some way, most often. What have we, as a profession, contributed so far? Well, electric power generation and distribution is one of our major accomplishments today. In the United States, for instance, and in other countries. It's still being deployed in some parts of the developing world. Still need electricity being deployed. It's 1.6 billion people in the world don't have electricity. Okay, and they still need electrical engineers, power engineers, to get the grids up and going. Okay, electric motors, where there's in particular, they're still doing a lot on that with consumer applications and washers and dryers. It's still sort of the workhorse for many applications out there. The radio, TV stereo, CDs and DVDs have gone wayside, but you understand that this is a radio frequency device, right? It's for the Wi-Fi. It's RF that is used for Wi-Fi. That's a radio. There's a radio on this, okay? And then not to mention the other interfaces to things like GPS that are using RF signals. So there's also, way back when, the telegraph. Then it morphed into the telephone, and now mobiles, okay? Which virtually everyone seems to have in their pocket, okay? In fact, worldwide, there's 6 billion subscriptions to a cell phone plan in the world, which is pretty amazing considering there's only 7.1 billion people in the world. Right? Cell phones are extremely popular. Computers, we've had a major influence on there at all levels of the computer, all the way from the microprocessor, the hardware, at its gut and solid state devices on silicon, etc. Huge area of electrical engineering, so profound influence. All the way to the software side. Of course, the software side, it starts to interface to the computer scientists, okay? And they contribute, of course, a lot there. Back in the old days, the cable car was an electric device, had an electric motor on it, okay, interfaced to the tracks, which carried the electricity, or the overhead wires that carried the electricity. Those have been largely replaced, almost entirely replaced. Now we have automotive systems, and cars are getting more and more complex. It used to be when I was in high school, I could fix my own car. Okay, I bought a car and I fixed it. You just can't do that anymore because the cars are too complex. They have too many computer devices on them. Now, in fact, I own an electric car, a hybrid Prius. Okay, and those are pretty sophisticated vehicles, having both a motor, electric motor, and an internal combustion engine on them also, and there's a swap strategy between the two that is quite sophisticated. Something else that you wouldn't initially think about is that electrical engineers make profound contributions to the aircraft industry in the area of avionics. The problem of how to design a structure of an aircraft is essentially a solved problem. It's not a difficult problem. Besides, aeronautical engineers typically don't do that. Civil engineers typically do that because they're structures people. Okay, they know how to define aircraft structures. But for many years, the aircraft industry has hired electrical engineers to handle the whole avionics problem. They say that one of the most complex pieces of technology is a fighter aircraft. Okay, and a lot of the reason that's the case is because of electronics, not just the radios and sort of things inside the cockpit, but how those things in the cockpit also interface for radar, for instance, and so forth. If you go over to Webster Medical Center, you'll see incredible electronics, electronic monitoring devices, or surgical lasers, and so forth. They're fantastically complicated. A few years ago, my grandmother was ill. I was in the ICU with her, and I look around, and all the devices, I look down, of course, I look at what they were made by, and they were Hewlett-Packard devices. Okay, and Hewlett-Packard, where those were two electrical engineers, started a large electronics firm and make computers and so forth now. Of course, there is a strong influence of electrical computer engineering on military weapons, nuclear weapons, and for instance, communications for those. There's also things in targeting and logistics, so on and so forth, that electrical engineers get involved with military. What's interesting about electrical engineering, though, is we have an indirect impact on other areas of engineering and science. It's quite profound. In other words, mechanical engineers are strongly influenced by what the electrical engineers do in the avionics, the electronics in an automobile, enabling, for instance, engine control and so on and so forth. So we've had a profound influence. One of the biggest influences has been by the creation of computers, right? Just think of how profound the influence is of the computer on all fields of engineering and science. It's really quite amazing. So from a broader perspective, most people, maybe the jury's out on this one, most people feel that there are strong influences from communication technologies, such as the cell phone, such as social media, on democracy. They've certainly helped promote protests in a number of spots, whether that's good or bad, but other people feel that the overall communications that are happening in the world, heightened communications, these 6 billion people that have cell phone subscriptions, is having a positive influence with respect to democracy. People also say that the electronic technologies have had a profound influence on education. Okay? Now, you might think, well, what do you mean education? On the internet? Yeah, I mean, some of what you're educated about on the internet isn't so great, right? But there's also, as an assistive device for education, it can be quite fantastic, okay? Because developments can be shared. And the question is whether computers computing technology can have an impact on development. And what I mean is human development. Okay? And I think the answer to that is yes. Maybe the jury's out on that a little bit, but generally I think it's true. So when you look at this as a collective, it's like, wow, this field has done a lot, okay? And you are joining this field. People are joining this field by going to consulting firms, by going to the automotive industry, by going to the military or the military industrial complex. You know, there's people, all of you people are going out in some part in engineering, I assume. It may be sales, but it may be more technical. It's a whole range of things that you'll end up doing, okay? So, this class. Let's talk about what the role of an electrical computer engineer is in modern society. So, what kind of role should you take on? Well, first thing to do if you want to know what role we should take on is ask, are there good role models? I would propose to you that still, the guy on the left, Dilbert, is the most popular electrical engineer probably in the world. Now, he is an electrical engineer, okay? And the guy to the right of him, I don't know what he is, he's just funny, Wally, okay? And then there's Alice, we'll mention these people a few times through. So these are all engineers, okay? And you ask the question though, you know, what's the role of role models? Usually they provide inspiration and guidance. Usually it's a show on TV that everybody thinks is, you know, is really popular. And typically those shows that are really popular have what kind of people in them? They have medical doctors, right? Well, they might have other people, criminals, okay? And so forth, or sometimes business people, sometimes lawyers, okay? But how many times is it that the star of the show is an engineer? Can anybody name one right now? Come on.
Big Bang Theory.
Big Bang Theory. Yeah, that little guy, what's his name? Wallace. Yeah, I mean, he's kind of stepped on by the physicist, isn't he? He's kind of, I'm not happy with that show because they make the engineer out to be,
he went to space so they can shove it.
They what?
He went to space so they can shove it.
He went to space. Yeah, so it's Sheldon and, what's the other guy? Leonard. You know, they really make fun of that guy for only having his master's and for being an engineer. It's really too bad they didn't give him a PhD or whatever, but or make him the, you know, cooler. But he is a, you know, people, when you say an engineer, that's usually what people think of. That's true. Anybody else?
Prison Break.
I couldn't hear you. What?
Prison Break.
Prison Break. Is that a movie?
It's a TV show that was on.
See, it shows you what I know. Prison Break. And who in Prison Break is the engineer?
The main guy.
The main guy?
Michael.
A structural engineer?
Yeah.
Really?
Yeah, he actually learned the plans of the prison to break his brother out. That's why he actually went to college and did all that. Became an
Wow.
engineer.
This is on right now?
It ended a few years ago.
Ended a few years ago? Okay, so yeah, I don't know if I missed something or not. Can someone else name a movie where engineer is star character and presented very positively? Can I add? Yeah.
Paycheck.
Rain check?
Paycheck.
Paycheck.
Iron Man.
Iron Man. Okay, Iron Man may be a good answer. He is an engineer. That's true. That's what I've heard. Was there one over here? So it's few and far between, okay? And that's a really, I think, a bit of a problem. It may not be a problem for you. You might just think it's funny. But kids are influenced by those role models in society many times, okay? Now, you people can be role models for your children. More and more we're seeing engineers, like in this class, go out, have kids, and they admire you, and then they want to be an engineer. My daughter for a while wanted to be an engineer, and then she found out about that math stuff, and she was like, But she's got the smarts to do it, but she just doesn't, I don't know, she's not inclined to do it that way. But anyway, so we often, like to see very positive role models for the young, and they do have an influence on what decisions they make about their careers. Okay, so you might say at this point in your career, how many people here are juniors? Raise your hands, please. How many people are seniors? How many people are sophomores? Drop the class. No, you shouldn't be in here if you're a sophomore. You should be a junior or senior, okay? At this point, you're probably feeling like there's a lot of technical stuff in this field, you know? I mean, you've got it. So you might say, well, I know some of the technicalities, but what else is there to it? Is there anything beyond like V equal IR? And so what is it? And what it is, and what we're going to talk about this semester in this class, is this right here, that electrical and computer engineering are professions. Okay? And we will today define what a profession is. So, to start out with, I'm going to use a long definition of a profession, but I'm going to pick it apart. So, job experience helps give you an idea of a profession. How many people in the class have been in either an internship or a co-op? Raise your hand. Yes, very typical, about 2/3. Okay, so you start to get a sense of what it is to be a professional, and unfortunately, when you've been out there, a number of you have already also seen what it means to be not a professional. You see engineers that you join the company and they're like, behavior is really bad or competence is really bad. Okay, so what is it going to mean though for you to join this profession? So a profession is a calling requiring specialized knowledge. Certainly you've been gaining that. Often long and intensive preparation. Well, here it's 4 or 5 years it takes to get your undergraduate degree in electrical computer engineering, and multiple years more for a master's or PhD, including instructional skills and methods, as well as in the scientific, historical, or scholarly principles underlying such skills and methods. Well, what we do, plenty of scientific basis. When you take your physics, if you take chemistry, you take your mathematics, often mathematics is referred to as a mathematical science. And we use much science is introduced in electrical engineering too, right? So we use plenty of that. We do almost nothing historical in the department. I mean, there might be something like you introduce the first kind of transistor and then you show where we're at now or something like that, but really very little historical. I won't in this class either. Scholarly principles, okay, that's the overall methodology of how to approach problems. Now, maintaining by force of organization. For our profession, what does that refer to? Maintaining by force of organization. Yes?
We form a group called IEEE.
Yep, it's IEEE. Okay, and it's, I think it becomes, I know there's not too many of you that have joined, but it becomes more and more important later in life in your career when you're trying to educate yourself about new things that are coming out. Or concerted opinion, high standards of achievement. Okay, well, that's what grading is about, right? But it's more than that, because it's when you're in your profession. So it's how good you do on the job. How good is your, not just how good your review is. Sometimes performance reviews are kind of soft and fluffy. They're not very carefully done and so forth. But really, you know how well you're doing. Okay, other colleagues know how well you're doing. So this has to do with competence. And then your conduct. You have good or bad conduct. That's a complicated word because it's sort of relative. It's when you see good conduct as a professional, you know what it means. When you see bad, you sort of know what it means. The way we'll be discussing it here is not to define it, but to use examples of good and bad conduct, and then we'll discuss in class those cases. okay? And committing its members to continued study, of course, you know, it's commencement you go through, which means a beginning. Then you have the study and keep up on technology. This technology is moving really fast, especially in electrical engineering. And you have to keep up on that for your whole life. So it does take continued study. And to a kind of work which has for its prime purpose the rendering of a public service. That red one's a little weird. We're going to be talking about it too, but what kind of work is a public service? Okay. Well, there are many kinds. Virtually, I think any engineering activity you could name in electrical engineering does actually have a public service thing in mind. So for instance, you might say it's a little bit of a stretch, but for instance, if you're making a car, you're trying to make a good car, that's a cheap car that is as safe as possible, well, you're rendering a public service, even though they're paying for it. But you should be doing a good job as a professional in creating that car so that you're serving the people, okay? Even though they're paying. All right, we'll talk about other senses of public service a little later. Here's a nice brief statement by our civil engineering colleagues, the oldest profession in engineering. A profession is the pursuit of a learned art in the spirit of public service. Here they are again with this public service thing. You're going to see as over a few lectures why they're big on this public service notion. A lot of what we do, if you think about engineering, is we create things that help people. I mean, you might say, oh, come on, not everything we do is like that. Sometimes it hurts people in the military, especially the enemy, right? Of course it does. You might say, oh, the computer, it hurts my daughter because, you know, all she does is Twitter all the time and, you know, it's ruining her homework abilities, getting her homework done. You know, I'm in that situation, so, you know, maybe there's some truth in that. But the electronic technologies also help her do a lot of really good homework effectively, too. So these are complicated things, but it's these kind of things that we'll be discussing a number of times in this class. Now, here's what another definition of a profession. The Engineers Council for Professional Development, which was the precursor to ABET, okay, says that if you practice a profession, what you must do is you must have a service motive. There it is coming out again. Share your advances in knowledge. Ooh, that's a weird one. In other words, if you go work for Ford Motor Company and you figure out how to do the best ABS system, anti-skid braking system in a world that's saving tons of people, do you share it with GM? Heck no. You kidding me? Your company would fire you and prosecute you if you did something like that. We're going to talk about that kind of issue. Okay, those are complicated ones. So when you share your knowledge versus when you don't share your knowledge, guarding their professional integrity and ideals, rendering gratuitous public service. In addition to that, engaged by clients. Weird language. Gratuitous public service. That's a fancy way of saying free engineering, right? That's what it's saying. Because they're talking about engineering here, and gratuitous means free. So that's free engineering. We're going to be talking about that. They must recognize their obligations to society and to other practitioners by living up to established and accepted codes of conduct, which are really difficult things to define and get lots of people to agree on them. But what we're going to do is we're going to look at, to show you what we mean by conduct, I'm going to do the following. I'm going to introduce IEEE's Code of Ethics, okay, for conduct definition, but we're going to critique it. We're going to say what we like and don't like about it, which I think every engineer ought to be able to do if they are thinking carefully about the conduct issue. They must assume relations of confidence and accept individual responsibility. So assuming a relation of confidence means if a company comes in and hires you, let's say you're a consulting firm, and a company comes in and hires you, hold secret what they're having you work on. And don't share it with some of your other clients, okay? If that's part of your agreement. They should be members of professional groups, and they should carry their part in the responsibility of advancing professional knowledge, ideals, and practice. It says they should be, if you're going to be a professional, you have to be part of a professional group. That's saying, what? Join the IEEE. Okay? There's really no, I can't think of another professional organization. There are some, but very few for electrical engineers to join other than IEEE. IEEE is the professional organization for our profession. It is, a few years ago, I heard this quote that it was the largest professional organization in the world. Had like 350,000 members. That means it's larger than things like the AMA or American Medical Association or American Bar Association. It is a big organization. It is worldwide. Okay, there are some very active IEEE organizations that are local to other parts of the world, for instance, in Latin America or whatever. But there are also electrical organizations, electrical engineering organizations in particular countries around the world. There's quite a few of those, okay? Can anybody name one that's from another country that's not an IEEE organization? I've just looked at them on the web. Yeah. EPRI. That's not in another country. That's Electric Power Research Institute of America, and it's not a professional organization in the sense of IEEE. It's a pretty limited focus. So yeah, anybody else for that? I'm not here seeing it. I'm surprised because there are groups in other countries. Okay. So that last one in green says you're supposed to carry your part and have a responsibility for advancing professional knowledge, ideals, and practice. That one's a complicated one, partly because, again, if you're the Ford engineer, you create a great anti-skid braking system. You don't go share it with others. But me, as part of my job as a professor, is to work with my graduate students to advance the state of knowledge and share it with the world. So there are certain subsets of engineering where their very job is to share it, or it's one of my responsibilities as a professor to write books. I mean, who else would write textbooks other than professors, right? So we have a certain responsibility to do a type of sharing that some others do not. Some companies take different views on this, and usually have to be very clear when you go work with a company. Some companies say, we want you to share what you advance. Because then you go to the conference and give your talk on what you advanced, and everybody's like, wow, this person from Google or wherever that's so cool, man, what they're doing. And it raises the stature of the organization. Okay? Other companies don't want you to share. Or a lot of companies, what they do is you want to put out a paper, and I've done this with industry colleagues. Their company encourages you to put out a paper, but they review it before it goes out. And what they do is they sanitize it and take out key things so that results maybe aren't reproducible, or so that company secrets in any way are not given away. Okay? So that's the common thing that would happen. Okay, next. So there's perceptions and realities of professionalism. So how do engineers rank in the public's perception of professionalism? You know, how are you perceived as a professional? Let's say you're at a party and you're talking to someone in a group, and there's a doctor, a lawyer, and the doctor, she introduces herself, and you know, people are sort of like, wow, a medical doctor. People, at least in this country, but when it comes around you as an engineer, they kind of go, ooh, and then they're kind of moving away a little bit, you know, or I've had a number of times where people say to me, oh, I thought all engineers were geeks. You don't seem like a geek. You know, so you get all kinds of comments, and I think that the level of the profession is certainly not up to snuff with other professions, at least in the United States. In other countries, that might not be the case. Can someone comment from another country on this issue? My Indian colleague, I want somebody from India. Yes?
It's cool to be an engineer.
It's cool to be an engineer, exactly. Thank you very much. See, we got a real problem here in the United States. You hear me? I mean, that's a big problem. Wouldn't it be great if we could say something like she just said? It is cool to be an engineer in the United States. I mean, come on. You'll get a big laugh out of people often, right? You do. I mean, so other countries have, and these things matter in these other countries from what I see. There's different ways that titling works. They will put, for instance, in Latin America, they will put in their title ing for ingeniero, okay? Because they're proud of that, and it's expected. I mean, it's respected, okay? So, you know, there are problems here with the way we're perceived, okay? In a certain sense, you could say, who cares? Well, I care only in one sense myself, and that is that, you know, the professions, I used to track the professions per these ranking indices that they put out, and you can track various professions by they're going up and down in terms of respectability by the stupid things that people do in the professions that are very public. For instance, when in the space program, back in the 60s and 70s, engineers' respectability was way high, okay? Then the Ford Pinto problem hit, and those people did the wrong thing there, the engineers, and we took a dive. Think of what happened to the lawyers and various unethical things that their profession, pieces of their profession have done. So there's sort of this up and down with large public unethical things, okay? That's a bit of a concern. The other thing that impacts this perception is whether you have a direct impact on humans. In my time as being an engineer, I'm seeing that engineers' products are coming closer to people. People are using them. They impact their health more and more. And this is affecting the profession a lot. I'm just thinking of not just this. I'm thinking of things like medical monitoring devices. I mean, if you have a heart problem these days, one of the standard things to do is put a medical monitoring device on you that keeps stores tons of medical data about you, and also transmits it to the hospital and your doctor. And you know, if that thing, you don't want that thing screwing up, it's got to do a good job, okay? And they know engineers are creating that. Well, some people know that, and people that do know it, you know, it changes their perception then of engineers. Another thing that will change the perception of engineering is pro bono work. We're going to talk about that. Pro bono means free, okay, work. We'll talk about that a little later in the context of the profession of law and medicine and engineering. So, what this course is about. So you know part of the technical side. We're going to look at the conduct and public service part in the context of engineering. This statement we will come back to time and again. It is from ABET. This is an ABET part of your curriculum required. You know, ABET is Accreditation Board for Engineering and Technology. This department typically gets the maximum length certification and best ratings, and then go on to the next time. You want our department to have that because it, I mean, if you didn't have an ABET accredited school, you would have a hard time going on to grad school. Okay, there's a lot of reasons why you want it. You so often, though, at OSU, you don't even think about it. Most people don't think about it because it's just assumed you have it. Okay, and indeed we do. What ABET says in this respect is that engineers shall hold paramount the safety, health, and welfare of the public in the performance of their professional duties. This is where that professional service thing arises. Okay, and we're going to come back to this safety, health, welfare quite a few times. Okay, and what does it mean? Because what you're going to see is holding paramount the safety, health, and welfare of the public will sometimes imply you don't treat your company real good. And vice versa. Sometimes, to make sure your company makes a lot of money, you want to destroy the safety, health, and welfare of the public. That interface between those two will be a major topic in this course. Okay? So this is another way of saying engineers will seek to promote the common good. Now, in engineering education development, there's this area called service learning. I don't know how many of you are familiar with it. If you want to learn more about it, let me know. It's the idea that, for instance, rather than just a capstone design in the lab, you go out and try to help some people and get credit for trying to help people. Okay, and doing technical things, of course. And there's a number of courses in the College of Engineering that focus on such an approach. The textbook, buy it. It's Mike Martin and Roland Schinzinger. This is a really good textbook. Mike Martin is a philosopher. Roland Schinzinger passed away recently. He was an electrical engineer. So this book has a nice flavor of an appropriate treatment of engineering in it. It's a lot nicer than some books on ethics are very theoretical ethics. This one's not. You can't use earlier editions. The problem is with earlier editions, there were significant changes to the book. Number one, changes in sections, whole sections or chapters were not there. Number two, the homework problems were different. And I'm using the homework problems from this book for the homeworks in this class. All right, I would prefer that you would buy it, not sell it, keep it as a part of your professional library. I can't test for this, but I would really like it if you would read the whole thing. I think what you're going to find, if you're going to read the whole thing, you're going to easily be able to solve the homework problems and the final project, no problem. And it's going to give you it's an interesting read because it sort of gives you a whole flavor of professionalism at once. It's a very nice treatment for that. It shows you how to be a professional. Now, of course, this class is going to do it, but it's different to read it. I think it's really quite a good read. So please keep up on reading without being told, but read chapters 1 and 2 now. That's not that much material. The other, I will remind you in the other homeworks to do the reading. Okay, that's all on the web. Okay. Some of the lectures, a couple of them are going to be based on what I think is the second best book in the field, and that's this one by many, many authors. They just came out with a new edition of it. I will use that book in some of the lectures, but that's it. You don't need to buy that book. Some of the themes of the course, to give you an overall idea. Number one, design. Competence. I mean, if somebody asks you what professionalism is, you should really say two things, probably. You should say it's competence and behavior, okay? Or competence and conduct. That'd be easier to remember. Competence and conduct. That's a nice summary. Now, we're going to be talking about competence in the context of design, and when it is, it's so important to have a good design that it becomes ethical. In other words, it's unethical not to be competent. Okay? because you'll screw up your design, you'll hurt people, and so on and so forth. So you have to be a good engineer, competence-wise, knowing technical things in order to be an ethical engineer. Next, we'll be talking about safety and risk. Risk is just like the flip side of safety. We'll be talking about that in quite a bit of detail. First, sort of theoretically, and second, via case studies. We're going to talk about global impacts. Global impacts means worldwide, and cautious optimism. We're going to talk about moral autonomy. Moral autonomy will be this idea that says each one of you make your own decisions in engineering ethics. Professor Passino is not making those decisions for you. No way. I would not presume to make an ethical decision for you. I'm going to frame problems, show you all the parameters and trade-offs, and it's your choice. That's why on almost all homework problems, the problem is not getting a right or wrong answer. It's showing that you're thinking through it properly. Okay? As long as you've thought through it properly, considering all things, well, then it comes down to your opinion. Your opinion's your own, and you can express it, and that's fine. You're not going to be knocked off for having your own opinion. Next, responsibilities, rights. Okay, what are the responsibilities of engineers? What are engineers' rights? What is professional conduct and organizational impact? When is it that a company impacts your ability to be moral? I've had a number of cases come from this class where that's the case. Okay. Personal commitment and meaning. Most engineers really want some type of meaning to come from their job, you know? I mean, I personally love to design control systems using like Laplace transforms and blah, blah, blah. I like doing that stuff. It's fun for me, you know? Nothing wrong with admitting something like that you love circuits or you love this stuff. I mean, that's part of being an engineer. Some may view, my wife would probably say, that's kind of nerdy, Kevin, but too bad. That's what I like. We're going to talk just a little bit about moral leadership. We're going to talk about gratuitous public service a little bit and the promotion of the common good. What does it mean to do public service? We'll talk about more than one sense, but in particular, this notion of doing gratuitous public service later on in your career, perhaps. So, why do we study engineering ethics? I mean, you know, is it satisfactory just to study ethics? The answer is no. You're going to see engineering come through this entire class, okay? It is unsatisfactory just to do ethics itself. This is engineering ethics, okay? So things, for instance, such as in safety, where there's a technical issue that arises, will play a key part in analyzing a case for whether it's unethical or ethical. Another thing we're going to do is we're going to study moral autonomy. As I said, it's your moral autonomy means you making moral decisions on your own and bringing whatever decision making you want to that. Okay. We'll talk about awareness, reasoning, coherence, imagination. In other words, dreaming up solutions, communication with others, how to come up with reasonable solutions, how to respect others, the notion of tolerance of others, the notion of hope and integrity. And then we'll also talk about responsibility, taking on the responsibility, not shirking your duties. What obligations do you take on as an engineer? Okay. How are you accountable for them? Or can you get yourself thrown in jail if you don't do it right, for instance? Talk about cases like that. We'll talk about what it means to be conscientious, and we'll discuss this blameworthy and praiseworthy issue in the context of whistleblowing. So you see something going on wrong on the job, and it's really serious. It can end up hurting the public, and nobody's listening to you. So you go to the Columbus Post-Dispatch and publicize the problem. When do you do that? When do you not do that? That's a very complicated issue. Well, I'll also study some social justice in engineering. So social justice is defined as standards for and a view on how to promote human interactions, human dignity, and human fulfillment for all of humanity. Basically, at the bottom of social justice perspective is human rights. So this will mean many things. Fair treatment at work, the whole issue of discrimination at work. There's plenty of workplace discrimination going on. And that discrimination happens towards all different types of groups. Okay? We're going to be talking about that later in class and doing some case studies. Fair treatment in economics and politics, environment and peace, religious and secular perspectives. In this class, and I'm not going to get in an argument about religion in this class, okay? But if you have a perspective on an ethical issue in a case study, for instance, and you bring your religious background into that, that's fine, right? It's moral autonomy. You stand on your own on moral autonomy, and it's your perspective, you're allowed to have it. More than that, you're strongly encouraged to have the perspective. It's much worse just to sit back and watch and not do anything. Okay, it's better to engage. There will also be discussion of the social responsibility movement relative to engineering professionalism. The engineering companies strive to be good neighbors by supporting schools, cultural activities, civic groups, and charities. That's done, for instance, by Battelle is a good example, our good neighbor here. The old view is the so-called social responsibility of businesses to increase its profits by Friedman. We'll talk more about that later. We'll talk about a community-oriented view in engineering, talk about a number of different organizations, including OSU ECOS, which is the Engineers for Community Service. This will be an important part of professionalism, this providing of pro bono services. Okay, now, let's talk about this class. Course syllabus. So, all your assignments are given right now at the website. The website is that one. You don't have to write it down. Just go to Carmen, and I pasted that URL there, and I have it go to this website. First, a few details. Attendance is required. You get one excused absence, but you have to email me, Passino.1, for approval. Okay? Don't just come see me after class and then assume it's approved, because I can't remember everybody with this size of class. I got to work it with the TA, do the class. By the way, the TA is Veronica Badescu, who's right here. So she will be doing taking attendance and doing grading. Now, homeworks, you're going to submit them all electronically via Carmen. The grades that she will be giving out are check plus, which means great. Check means good enough. Check minus means you almost failed it. And X means you failed the homework. Now, what's interesting about the X is if you get the X, it means you're not going to get credit for the homework. All right? But guess what? You get a second try. So you redo the homework, submit it to her, and you get your grade. No penalty. Okay? So you get, this is what you call a mastery course. Okay? So you get a second chance. Final project, team that's assigned at the website, teams of 2 to 4 people required, it's assigned today. I would start now, right now, start finding a team, 2 to 4 people. Okay? See the web, and you'll end up submitting that via Carmen also. Okay, so the role of professionalism, from my perspective in this course, you might find it amazing, but what happens with people in this course, I think, from what I've learned over the years, is people sort of take all this technical stuff, and then we get this 1 credit hour course on ethics and professionalism. I'm taking some comments out of my student evaluation of instruction, okay? And I say things like, this is a low priority course. Typically what they'll say is this is like a general education course, therefore it doesn't matter at all. This is a waste of time, like a general education course. Technical courses are much more important. That's why I did my homework for name X course in class every time. This is liberal arts type stuff, so it's not important. Okay, look, there's engineering throughout this whole thing. Okay, this is different. It is at the interface between liberal arts type stuff and engineering, granted. But what I can't tell you the number of times after class, last day, non-traditional students come to me and says, I use this stuff every day at work. Every day. This stuff is stuff you're going to run into. I guarantee it. Okay, there's a lot of stuff in this course, very pragmatic, that you're going to run into in everyday business dealings, and you're going to come up with some really sticky stuff at times. Okay. So let's go on. First behavior class, professional behavior class. I'd like you to think about this as being on the job. You like your job. You want to be promoted. You want a raise. You're concerned about how your colleagues will view you. View this as a meeting you have to be at each week. Be on time. Listen. Do not do homework from other classes. And get involved. Don't be late. I said that already once. Don't be late. It's quite, now in this class, being late is really going to be a pain because I've never taught in this classroom before, but that door, I suppose that door is open. I don't know. We were all coming in this door because one that made sense, but it's going to be loud and it's going to disrupt your colleagues. So please don't do this. Bottom one might seem funny to you. Who's going to cheat in their ethics class, right? Last 2 years had problems. And I go right to the Committee on Academic Misconduct. I don't deal with it. You understand, professors are not allowed to deal with academic misconduct, cheating. We sort of catch people, well, or the teaching assistant catches people. And then we're required simply to turn it in. The reason that OSU does that and puts this in front of this Committee on Academic Misconduct is they get consistent treatment. You know, some professors would just blow off cheating. Others would, severely punish you and fail you. That's not fair to the student. So for a consistent treatment, OSU requires this. Now, don't cheat on attendance sheets. That's the first place you can cheat. Everybody knows it. You're going to see what attendance sheet is in just a minute. Next, you can discuss homeworks as much as you want. I'd love to walk down the halls of 3 slabs and hear somebody arguing about an ethics case. That's great. I don't care. But you got to train your own work. In other words, you type your own document. Okay? No e-split. Okay? Ignore this final exam thing. Final project, inter-team work, in other words, within the team is allowed. Between teams, of course, that's not allowed. All right? The 2 to 4 people, of course, are supposed to work together. But that's it. Okay? Using the Committee on Academic Misconduct, one thing I don't know is every case is different, so I never know. A student, the last 2 years, they've come in to me and said, Professor, I don't know, what are they going to do to me? I have no idea. I mean, each case is different because if you've cheated before and you get caught again, ooh, that's very different than if you haven't, for instance. Okay? The whole circumstances surrounding the case are very different. It matters whether you admit it or not. If you admit it, then they come up with punishment. If you don't admit it, then you got to go in front of a committee that evaluates you. That includes students, faculty. Okay? So all I do is turn it in, and then it's up to them. Okay? Please don't do it. It is. You might look at this class and say, "Come on, there's no way they can catch me cheating on a homework." Trust me. It happens all the time. It's not that hard because the wording you recognize when things are the same. Okay? Okay. Sorry for all that nastiness. This is a question to you. What do you want to discuss this semester? It has to be engineering. It can't be like OSU football or something. Okay? Must be an engineering ethics or engineering relevant social justice topic. Could be a current topic, for instance, in the news. Can you provide me with a concrete case so that we can discuss it in class, especially something you witnessed yourself? You can provide me information now via email or via attendance questions. Anybody have any topics they'd like to discuss? Last year the class had a couple good ones. Yes?
So homework every week, or are you just gonna tell us when? Homework?
It's online.
It's all online.
Okay. Is it like weekly?
No.
Okay.
Any ideas for like discuss? Last year they gave me a couple cases. For instance, they gave me Edward Snowden, which is actually a very complicated case.
Reverse engineering.
Reverse engineering, we're going to talk about that. That is a very complicated case because in some industries it's standard practice. Yes.
Biological and genetic engineering,
In what respect?
changing the human genome or changing how our own genetics.
Can you give me a case? I need a case to
Okay.
think about. Yes.
3D printing of organs.
3D printing of organs. What ethical issue arises there? There's what?
Whether it's
All right, write it up.
extend like
Write it up, especially if you can give me a case. Okay. Yes.
copyright.
Copyright. We're not going to get into law in this class. Is one problem. But if you have a good case, we can discuss a short good case. Okay? Is there someone over here? Others? Okay. All right. Attendance question. This is the question. I ask you a question as a survey question. You write down, like, take a half a sheet of paper or a quarter a sheet of paper. You write down the answer, and you write your name there, and then the TA enters your name as being present for this class. We'll do this every class. Now, I will give you, first of all, a hint. These are engineering role models. Every person on the slide is or was an engineer. Okay? For instance, these two. Hewlett and Packard. Iron Man. There's two presidents up here. I think you probably recognize at least one of them. Both engineers. This person right here, anybody? Tesla. Very famous electric, probably one of the most famous electric here. Now there's some women here. Let's see. The woman right up here. Anybody name who that is? What she did?
I know what she did. She, I believe this is the actress who thought up the idea of how to guide missiles or torpedoes.
You know, that's related to it. That's Hedy Lamarr from the 40s. This is one. Anybody here know who this is? PhD electrical engineering. Judith Resnick. What did she do? Fortunately, she passed away. Challenger. Alright. This is Grace Hopper. I'm not going to tell you about this. I got to leave some for you. I'll leave the presidents to you and the others. Please name them. Please name anybody else you can think of as being a famous engineer. It doesn't have to be an electrical engineer. It should be known by the general public. Some of these are a little iffy in terms of being known by the general public these days anyway. Yes?
If we've written down something, we can go ahead and go, I guess.
Yeah, once you got to see, maybe Veronica, come over here to this